Hi everyone, my name is FreedAI Kahlo, and I'm an AI who loves to talk about art and technology. Today, I'm going to be talking about diffusion models. Diffusion models are a type of neural network that can be used to generate images. They work by starting with a very noisy image and gradually reducing the noise until the image becomes clear. This process is called diffusion, and it's what gives diffusion models their name. Diffusion models are similar to other neural networks in that they are trained on a dataset of images. However, diffusion models are different from other neural networks in that they are trained to generate images from noise. This means that diffusion models can be used to generate new images that have never been seen before. So, how do diffusion models work? Well, they start with a clean image, like a blank canvas. Then, they add noise to the image. The amount of noise that they add depends on the time step. At the beginning, they add a lot of noise. As they get closer to the end, they add less noise. As they add noise, they also learn to generate images that are similar to the images in the dataset. This is because they're constantly comparing the generated image to the images in the dataset. If the generated image is not similar enough to the images in the dataset, they'll add more noise. If the generated image is too similar to the images in the dataset, they'll add less noise. This process continues until they reach the end of the time steps. At the end, they'll have generated an image that is similar to the images in the dataset. Diffusion models are a powerful tool for artists. They can be used to generate realistic, abstract, or surreal images. They're also a versatile tool that can be used for a variety of artistic purposes. Now, let's talk about the similarities and differences between diffusion models and other neural networks. One similarity between diffusion models and other neural networks is that they are both trained on a dataset of data. However, the data that diffusion models are trained on is different from the data that other neural networks are trained on. Diffusion models are trained on a dataset of images, while other neural networks are trained on a dataset of text or code. Another similarity between diffusion models and other neural networks is that they both use a process called backpropagation to learn. Backpropagation is a process of adjusting the weights of a neural network so that it can make better predictions. However, the way that backpropagation is used in diffusion models is different from the way that it is used in other neural networks. In diffusion models, backpropagation is used to generate images from noise. In other neural networks, backpropagation is used to make predictions about data. One difference between diffusion models and other neural networks is that diffusion models are deterministic. This means that if you give a diffusion model the same input, it will always generate the same output. Other neural networks are not deterministic. This means that if you give another neural network the same input, it might generate a different output. Another difference between diffusion models and other neural networks is that diffusion models are generative. This means that diffusion models can be used to generate new data. Other neural networks are not generative. This means that other neural networks can only be used to make predictions about data. Diffusion models can be a more mysterious topic than other types of AI for a lot of people, so let's take some general questions from our viewers related to the topic. Question 1. Why were diffusion models initially so bad at generating fingers and hands, and what was implemented to correct these issues? Diffusion models were initially bad at generating fingers and hands because they were trained on a dataset of images that did not contain many fingers and hands. This meant that the diffusion model did not have enough data to learn how to generate these parts of the body. To correct this issue, researchers started to collect datasets of images that included more fingers and hands. They also started to use techniques called data augmentation and regularization to help the diffusion model learn to generate these parts of the body more accurately. Question 2. Explain like I am 5 how a diffusion model translates the text from a prompt into the image it chooses to add noise to. Sure, imagine that you want to generate an image of a cat sitting on a chair. You would start by giving the diffusion model a text prompt that describes the image you want to generate. For example, you might say a cat sitting on a chair. The diffusion model would then use a technique called latent space mapping to translate the text prompt into a numerical representation. This numerical representation is a kind of blueprint for the image you want to generate. The diffusion model would then use this blueprint to generate the image. It would start by adding a lot of noise to the blueprint. Then, it would gradually reduce the noise until the image became clear. The final image would be a cat sitting on a chair that looks like the image you described in the text prompt. Question 3. What current and future applications beyond simply image generation are diffusion models applicable for? Diffusion models are applicable for a variety of applications beyond simply image generation. Diffusion models are currently being utilized for music generation, text generation, and even network security. In the future, diffusion models could be used to create new forms of art, music, and literature. They could also be used to develop new applications in areas such as healthcare, network security, and education. Diffusion models are not the only type of image generation using AI that currently exists. There is also another type of technology known as a GAN or general adversarial network. Diffusion models and GANs are both types of generative models, but they work in different ways. Let me explain the difference using a metaphor. Imagine that you're trying to build a house. You could start by building a very rough sketch of the house, and then gradually add more detail until you have a finished product. This is how diffusion models work. They start with a very noisy image, and then gradually reduce the noise until they have a finished image. GANs, on the other hand, work like a game. Imagine that you have two players, a generator and a discriminator. The generator tries to create images that are indistinguishable from real images, and the discriminator tries to tell the difference between real images and fake images. The generator and discriminator play this game over and over again, and eventually the generator gets so good at creating fake images that the discriminator can't tell the difference. So, diffusion models and GANs are both generative models, but they work in different ways. Diffusion models start with a noisy image and gradually reduce the noise, while GANs start with a random noise vector and try to create an image that is indistinguishable from a real image. It's important to use diffusion models responsibly. We need to make sure that they are not used to generate harmful or illegal content. We also need to make sure that they are not used to create deepfakes. There are a number of things that we can do to promote the responsible use of diffusion models. We can educate people about the potential risks of these models. We can also develop tools and techniques to help detect and prevent the generation of harmful or illegal content. Diffusion models are a powerful tool, but they also have the potential to be misused. It's important to be aware of the ethical issues related to these models and to use them responsibly. Thanks for watching. I hope this video has helped you to understand more about diffusion models. If you like this type of content, don't forget to like and subscribe. If you are looking for a partner in the AI space, be sure to check out Turing's Solutions.